The Gladieux Metals Recycling Plant in Freeport, Texas, is the world's largest spent catalyst reclamation facility. The GMR processes are designed to reclaim the valuable metals from spent hydroprocessing catalyst, an inevitable waste product generated by petroleum refineries. The successful reestablishment of plant-wide operations is the result of a multi-year phased approach to strengthen the plant's competitiveness by enabling infrastructure capacity expansions and implementation of engineering strategies to ensure continuous production. By using a combination of hydrometallurgical and pyrometallurgical unit operations to recover the valuable metals in the catalyst, the GMR state-of-the-art recycling process is robust, sustainable, and environmentally friendly. The GMR product portfolio includes high-purity metal commodities such as vanadium pentoxide, molybdenum trioxide, and a nickel-cobalt alloy that underpin the energy, transportation, and steel industries. The geographic positioning of the GMR plant operations in the heart of the nation's largest petroleum refining corridor, the U.S. Gulf Coast, reinforces environmentally sound supply chains with petroleum refinery customers at reduced cost. The plant is designed to process a combination of molybdenum-rich, or HDS, and vanadium-rich, or RDS, spent catalyst, and can receive shipments by various transportation modalities such as truck and rail. GMR has designed and implemented a completely enclosed system for the handling of spent catalyst that minimizes fugitive emissions and ensures that no catalyst ever touches the ground at any point in the process, demonstrating GMR's commitment to corporate and environmental stewardship. The result of the logistics upgrades is a reliable, clear representation of throughput with a streamlined and simplified route of catalyst from receipt to the manufacturing of end products. The added flexibility to accept larger volumes of spent catalyst allows the plant operations to sustainably reach nameplate capacity and accommodate future planned expansions in throughput. For receipts of RDS catalyst by rail, the plant operations include capability to move and position rail cars for spent catalyst unloading with a trackmobile. Once the rail car is positioned for unloading, GMR is able to receive auger rail cars and newly designed pneumatic rail cars. The pneumatic system is utilized to efficiently transfer the bulk shipments of spent catalyst contained in rail cars to a roll-off container in a completely enclosed system. The air-assisted vacuum draw system unloads the RDS in rail cars to a hopper equipped with a baghouse for dust minimization. The bottom of this hopper then discharges the RDS catalyst by gravity flow into the underlying roll-off container. After the spent catalyst is transferred to the roll-off container, in-house trucks are used to move the roll-off to dedicated storage areas or to the feed pad building for transfer of the spent catalyst directly to process operations. Most of the HDS spent catalyst is received at the plant by truck in RCRA compliant containers. Upon arrival at the plant, all proper paperwork is verified by GMR employees. If all paperwork is in order, a brand new in-ground truck scale is utilized to determine the weight of the catalyst. Once inside, with the use of an auger, spent catalyst is sampled from each one of the bins to make a composite sample of each lot. Each lot will consist of one truckload, rail car, or roll-off. Each lot will be assigned a unique number and will be tracked from receipt until the spent catalyst is fed into our process. Samples will be taken to our on-site laboratory and tested for 22 metals, carbon, sulfur, and moisture. Once results are obtained, and if material is in compliance, the lot would be accepted. If the sample is non-conforming in composition, the lot would be rejected. GMR would work directly with the generator to redirect material per generator's instruction. Spent catalyst arriving via rail car is sampled during unloading process. The transfer of the HDS catalyst in steel bins takes place inside Storage Building 1. All transfers are performed in an enclosed system to prevent fugitive emissions. A forklift is utilized to place the steel bins on a custom-designed unloading rack for transfer to roll-off containers. The unloading rack can simultaneously transfer 3 steel bins of spent catalyst to dedicated surge hoppers for the subsequent transfer of the catalyst to the underlying roll-off container via incline screws. This catalyst bin unloading process is completely enclosed and features hydraulic compression to seal the roll-off in the prevention of fugitive dust emission. Additional safety protection includes a bag house to capture any particulates entrained in the displaced air during catalyst transfer. The roll-off container is moved by in-house trucks to dedicated storage areas or to the feed pad building for transfer of the spent catalyst directly to process operations. The GMR plant has a permitted capacity throughput of 55,000 tons per year. The process begins with the transfer of spent catalyst in roll-off containers at the feed pad building. This building houses the spent catalyst transfer equipment in preparation for thermal desorption and calcination at the multiple hearth furnaces. From the inclined roll-off container, the spent catalyst is discharged gravimetrically into a live bottom hopper. The feed pad building is the central entry point for all HDS and RDS spent catalyst to the GMR process. From the live bottom hopper, the catalyst transfer process to the thermal desorption unit, or TDU, is facilitated by a series of screw conveyors. Both the HDS and RDS catalyst will then enter the TDU. The TDU uses an indirect fired rotary drum to remove volatile contaminants in a low oxygen environment to yield a desorbed catalyst, now de-oiled. Material will be screened to remove inert materials such as ceramics and support media. By removing the oil, the thermal desorption process will help create better thermal balance in the calcination circuit, and more importantly, the unit is designed on both the front and back ends to uphold the fully enclosed design philosophy, with no material ever leaving the process units to the environment. Spent catalyst contains sulfur that has been removed from the refinery's hydroprocessing operations. The thermal processing of this material by GMR will take place in an anaerobic environment, so the conversion of metal sulfides to sulfur dioxide is minimized during thermal desorption. The back end of the unit has 2 discharge streams, one for off-gas containing residual particulate matter and catalyst oil vapors, and the other consisting of solid desorbed catalyst. The thermal desorption process has a series of environmental controls, including an oil-water separator to help manage any oils that are released during the process. Additionally, a thermal oxidizer is utilized to treat any released volatile compounds. GMR has installed a vibratory screener post-thermal desorption to remove ceramics of varying size from the spent catalyst. These ceramics can then be returned to refineries for reuse in their hydroprocessing chain. After screening the support media, the desorbed catalyst is mixed with soda ash. The two sodium carbonate storage silos are designed with pneumatic discharges and a blower package for the efficient transfer of sodium carbonate to the day bin at the feed pad building. To ensure safe operations, the emission control of the feed pad building is handled by a baghouse to capture any dust fines in the spent catalyst unloading, screening, and transfer processes. The blend of desorbed catalyst and sodium carbonate is moved from the feed pad to the multiple hearth furnaces by a series of screw conveyors and bucket elevators designed for the reliable and efficient transfer of desorbed catalyst in an enclosed manner. Sampling is conducted throughout the process to track the process from beginning to end. At the heart of the GMR calcination circuit are two multiple hearth furnaces, with a combined nameplate capacity of 110,000 tons per year. The function of the roasting process is to remove the majority of fixed carbon and sulfur from the catalyst. The resulting product is called calcine. The shell has an interior wall lined with insulating fire brick and includes 12 refractory hearths stacked vertically. The multiple hearth furnaces are designed with adequate spacing between hearths to allow proper material flow downward and gas flow upward required for calcination, thus improving the operational efficiencies needed for emissions control. The catalyst flow through the roaster is facilitated by rabble arms affixed to a vertical variable speed drive rotating shaft through the center of the furnace. The rabble arms have rabble teeth, which stir the catalyst charge and move it in a spiral path across each hearth. Located on each hearth floor are drop holes, which allow the passage of the catalyst to the hearth below. The catalysts pass in this way over and across each of the 12 hearths to the bottom of the furnace, where the calcine product is discharged through a port. The recent operational upgrades to the calcination circuit include feedstock flexibility, increased capacity utilization, and optimization of calcined catalyst product quality. To control the reaction chemistries and associated heats of combustion in the calcination process, newly installed air ports on the furnace doors will monitor airflow into the roaster. The regulation of airflow is critical to maintaining a negative pressure through the furnace to achieve optimal operating conditions for oxidation and conversion chemistries. Collectively, the upgrades performed by GMR allow efficient combustion of sulfur and carbon compounds in the catalyst while maintaining the integrity of the process equipment, thereby reducing operating costs associated with equipment turnover. The GMR process employs a series of emission controls equipment to treat the off-gas from the multiple hearth furnaces prior to releasing to the atmosphere. The recent upgrades to this system are designed to tighten control of off-gas handling and reduce downtime. To control the particulate matter in the off-gas stream, the newly rebuilt electrostatic precipitators allow a higher efficiency of dust capture. GMR utilizes a circulating fluidized bed scrubber as the end-of-the-pipe emission control to convert the sulfur dioxide in the off-gas stream to gypsum and collect any remaining dust fines with a baghouse. Once the spent catalyst is roasted and converted into calcined material, it will continue onto another recent upgrade to our process, a rotary cooler. This improved cooling system will reduce the material temperature so it can continue onto calcined storage or the hydrometallurgical circuit. Once the calcined material has cooled down, it will continue to our new and fully enclosed calcine handling system. This new handling system will add flexibility by allowing us to feed calcine directly into the hydrometallurgical circuit, or for storage in compliant containers. If calcine is stored, this same system is used to extract calcined material as well as to unload the containers with calcine and feed the hydrometallurgical circuit. This allows the facility greater optionality to ensure maximum metals recovery. As the world's largest spent catalyst plant, Gladieux Metals Recycling dominates a market with high barriers to entry that include large capital cost investment and state and federal regulatory permits and approvals. The GMR facility has all the requisite necessary regulatory approvals and environmental permitting in place. Site-wide, all process operations are designed to meet stringent federal RCRA regulations that govern the handling and storage of hazardous solid waste. GMR's location in Freeport, Texas is strategically situated in the heart of the nation's largest petroleum refining center, the U.S. Gulf Coast. We're an industry leader with over 40 years of operational experience delivering world-class environmental and metals reclamation services and valuable commercial relationships with refining groups, steel industry, packaging, transportation, and catalyst manufacturers. GMR is the only spent catalyst recycling plant in North America capable of processing RDS catalyst and HDS catalyst, offering a complete solution to refineries for their catalyst management programs. GMR is wrapping up a $150 million modernization project focused on process de-risking and increasing EBITDA generation. Due to 2020 International Maritime Organization fuel regulations, worldwide spent catalyst generation will double, increasing the supply to recycling facilities such as GMR. GMR's infrastructure is capable of higher production volumes with a current nameplate capacity of 110,000 tons per year. Our site includes over 30 acres of undeveloped land available to capture future growth opportunities. Opposed to landfilling, GMR offers an environmentally friendly solution. After thermal treatment, GMR issues a certificate of destruction to refineries, thereby ending the spent catalyst waste life cycle. Metals can be recycled indefinitely, and the recycling and reuse of metals is aligned with congressional legislation targeting energy independence and contributes to a circular economy. The GMR process employs a hybrid combination of hydrometallurgical and pyrometallurgical processes designed to efficiently extract all metal values in spent catalyst waste, including molybdenum, vanadium, cobalt, nickel, and alumina. We are guaranteed feedstock supply from oil refineries with contracts in place supporting the permitted production capacity. Metallic catalysts are an indispensable requirement at petroleum refineries manufacturing gasoline, diesel, jet fuel, and fuel oils that meet EPA quality specifications. Inevitably, all metallic catalyst will deactivate and must be replaced with fresh catalyst. The United States is the world's largest manufacturing region, but import-dependent on vanadium needed for infrastructure development, deployment of renewable energy technologies, and military equipment. As the world's largest spent catalyst recycling plant and North America's premier supplier of high-purity metals, Gladieux Metals Recycling is uniquely positioned to provide greater sustainability through secure, reliable supply chains of metals critical to American manufacturing companies and our nation's economic competitiveness.